Hello students, welcome to all. This is Dr. Vigneshwar Mekha, lecturer in Geography, Government Degree College for Women's, Begumpet, Hyderabad. In this session, we are going to discuss about weathering, definition and classification. And because of this module is very vast, the module is divided into two parts. And in this session, we are going to discuss about part 1. The points to be covered in this session, that is part 1 video of the weathering of introduction to weathering, definition of weathering, factors controlling the weathering, and types of weathering. First, introduction to weathering. Rocks, minerals, soils normally change their structure under the action or the influence of certain environmental forces. Biological activity, extreme weather and agents of erosion such as water, wind and ice are examples of environmental forces that influence the conditions breakdown, wearing away and losing of rocks and soils. The weathering is the breakdown and alteration of rocks and minerals at or near the Earth's surface into the products that are more in the equilibrium with the conditions found in this environment. Most rocks and minerals are formed deep within the Earth's crust, where the temperature and pressure differ greatly from the surface of the Earth. Because the physical and chemical nature of materials formed in the interior of the Earth are characteristically in disequilibrium with conditions occurring on the surface. Because of this disequilibrium, these materials are easily attacked, decomposed, and eroded by the various chemical and physical surface processes. Weathering is the first step for a number of other geomorphic and biological processes. The products of weathering are a major source of sediments for erosion and deposition processes. Many types of sedimentary rocks are composed of particles that have been weathered, eroded, transported, and terminally deposited in the depressions or the basins. Weathering also contributes to the formation of soil by providing mineral particles such as soil, sand, salt, clay, elements in compounds extracted from the rocks and minerals by weathering processes supply nutrients for the plant uptake. The fact is that the oceans are the saline in the result of these release of iron salts from rock and minerals on the continents. Leaking and runoff transport those ions from land to the ocean basins where they accumulate in the seawater. Weathering is a process that is fundamental to many other aspects of hydrosphere, lithosphere and biosphere. The products of weathering. The process of weathering can result in the following 3 outcomes on rocks and minerals. 1. The complete loss of particular atoms and or compounds from the weathered surface. The 2 is the addition of specific atoms or compounds to the weathered surface. And 3 is a breakdown of one mass into 2 or more masses, which with no chemical change in the mineral or rock structure. Now, we will look into the definition of weathering. Here, an attempt is also made to define about weathering besides weathering, erosion, mass wasting, and deposition also. First, let us look at the definition of the weathering. Weathering is the physical disintegration or chemical alteration of rocks at or near the surface of the earth. Erosion is the physical removal and transportation of weathered material by water, wind, ice, or gravity, etc. If you take the mass wasting, it is the transfer or the movement of rock or soil downslope primarily by gravity or gravitational force. Whereas the deposition is the process by which weathered and eroded materials are laid down or placed in a location that is different from their source or the origin place. The definition of weathering can be also given as the disintegration or the decomposition of various rocks in a place or or near the ground surface. It is primarily concerned with the reduction of a rock mass to a form and size which is susceptible to erosion and accompanied by agencies like mass movement, running water, etc. Dear students, the point to note that weathering, erosion, mass wasting, and depositional processes occur at or near the Earth's surface and produce changes to the landscape or land features that influence surface and subsurface topography and landform development. These processes are all very important to the rock cycle because over geological time, weathering, erosion, and mass wasting transform solid rock into the sediments and soil that result in the redeposition of material from forming a new sedimentary rocks. Now, let us look into the various stages in weathering. 4 stages of weathering have been recognized universally by several scientists all over the world. So now let us look into the first stage of weathering. Initiation of physical weathering when the parent rocks change to coarse and fine-grained detritus. Present-day weathering activity is sometimes terminated under severe environmental conditions and active demolition. The second stage. The second stage involves the alkaline reactions in the zone of weathering due to the leaking of bases from the primary minerals. Secondary minerals are produced during this stage by oxidation, hydration, hydrolysis, and carbonation of the primary minerals. The dominant secondary minerals produced belong to the monilionite and non-tronite groups. All the recent ski and surficial materials on the slopes of the mountainous terrain reflects the second stage of weathering. Next is third stage of weathering. Third stage is characterized by the further removal of alkaline and alkaline earth elements from the products of weathering. Consequently, the acidity is activated in the zone of weathering. Under these conditions, halloysite and Kaolinite groups of secondary minerals are produced dominantly. This stage of weathering is predominant under the conditions of slow or retarded denudation and also relatively high rainfall or wetting. The fourth stage of weathering. This stage involves the formation of a residual allitic weathering crust enriched in iron and alumino oxides. The attainment of this stage is conditioned by the presence of intensive chemical deposition of the primary minerals in rocks coupled with very slow denudation under hot and humid conditions. The red Alps of the humid subtropical areas best represent the allied type of weathering. The red colorization is due to the accumulation of ferric hydroxides in the residuum. The weathering process may be controlled by the many factors. There are various factors that control in the weathering processes. The types, rates of weathering differ at the regional and local spatial scales. In addition to the climate, the type of rock, that is lithology, and the nature and the amount of fractures or the other weaknesses in it are major influences on the effectiveness of the various rock weathering processes. We discuss the four important weathering factors that influence the weathering. They are climate, rock type, slope orientation, and vegetation. Let us look into each one of these factors, how they are impacting or the controlling the rock weathering. First, let us discuss about the climate. Different climate conditions are associated with the different weathering processes. For example, chemical weathering is particularly effective and rapid in humid type of climates. Chemical weathering is much more restricted in arid climates. Arid regions typically receive sufficient much of a physical weathering, but salt crystals growth and the hydration of the salts. Abundant salts, high humidity, and contact with the seawater make salt weathering processes very effective in marine coastal locations than in other. The second is rock type. Weathering is greatly influenced by the character of the bedrock, that is hard or soft, soluble or insoluble, broken or unbroken rock. The areas of various rock types undergoes differential weathering and erosion. Easily eroded rocks exhibit more extensive effects of weathering and erosion than the resistant rocks. And the third is the orientation of slope or the slope orientation. The geographic orientation of a shore, whether it faces north or south, east or west, controls the slope's exposure to the sun, wind, and precipitation. And the next is vegetation cover. Although the vegetation cover can protect rock by shielding it from raindrop impact and providing roots to stabilize soil. It also produces organic acid from the partial decay of the organic matter. These acids contribute to the chemical weathering. Plants' roots can enter in crevices and break up a rock, exerting enough pressure to force rock segments apart, thereby exposing greater surface area to the other weathering processes. In the complexity of nature, physical weathering and chemical weathering processes usually operate together. Of course, in all these is the crucial factor for the processes required along periods of time to operate. Therefore, the vegetation cover impacts or controls the process of rock weathering. Now, we move to types of weathering. The weathering can be divided into the four: mechanical, chemical, biological, and differential weathering also. Here, an attempt is made to discuss about three types of weathering, that is mechanical, chemical, and biological weathering only. Mechanical weathering, also known as the physical weathering. Mechanical weathering is the physical disintegration and reduction in the size of the rocks without changing their chemical composition. For example, exfoliation, frost wedging, salt wedging, temperature changes, and abrasion. The chemical weathering decomposes, dissolves, alters, or weakens the rocks through chemical processes to form residual materials. For example, carbonation, hydration, hydrolysis, oxidation, and solution. And the third is biological weathering. It is the disintegration or the decay of rocks and minerals caused by the chemical or physical agents of organisms. For example, organic activity from lichen and algae, rock disintegration by the plant or root growth, burrowing and tunneling organisms, and acid secretion, etc. Let us discuss about the mechanical weathering in detail. Mechanical weathering is the physical disintegration and a reduction in the size of rocks without changing their chemical composition. It is by the process of the exfoliation, frost wedging, salt wedging, temperature changes, and abrasion. Let us discuss about the exfoliation process. Exfoliation is a mechanical weathering process in which pressure in a rock is released, that is unloading along parallel alignments, sheet joints near the surface of the bedrock, and layers or the slabs of the rock along these alignments break off from the bedrock and move downhill by the gravity. Exfoliation primarily occurs in intrusive igneous or metamorphosed rocks that are exposed at the Earth's surface. Exfoliation can occur both very slow or very rapidly as a form of mass resting. Large rocks characterized by the exfoliation are commonly referred to as exfoliation domes. Table Rock Mountain in South Carolina, Enchanted Rock in Texas, are both examples of exfoliation zones with the large slabs of rock exfoliating from the bedrock. The Bhonagiri Fort in Bhonagiri, Yadadri Bhonagiri district of Telangana is also best example for the exfoliation rock. The pictures on the screen discloses you about the exfoliated rocks. Exfoliated. The next is the frost wedging. It is a mechanical weathering process caused by the freeze-thaw action of water that is trapped between cracks in the rocks. When water freezes, it expands and applies pressure to the surrounding rock, forces the rock to be accommodate the expansion of the ice. The frost wedging process gradually weakens fractures and breaks the rock through repetitive freeze or weathering cycles. Frost wedging generally produces angular blocks and talus material. Talus is term used to describe weathered rock fragments deposited at the base of a hill slope or mountain. Next is temperature changes. Diurnal and seasonal temperature changes affect certain minerals and facilitates the mechanical weathering of bedrock. Okay. Warmer temperatures may cause some minerals to expand, and cooler temperatures cause them to contract. This gradual expansion and contraction of the mineral grains weakens the rock, causing it break apart into a smaller fragments or to fraction. The temperature changes process is more common in desert climates or dry climates because they experience extreme fluctuations in daily temperature ranges or diurnal temperature changes. The temperature changes are often not the dominant form of weathering, but instead temperature changes tend to accelerate other forms of weathering already taking place or occurring. The insulation weathering, thermal expansion and contraction has been explained in the following table. The next is the salt wedging. Salt wedging occurs when the salts crystallize out of solution as water evaporates. As the salt crystals grow, they apply pressure. Salt crystals grow, they apply pressure to the surrounding rock, weakening it until it eventually cracks and breaks down, enabling the salt crystal to continue grow. Salt wedging is most common in dry climates, high evaporative climates such as the deserts. Then abrasion. It occurs when rocks collide against each other while they are transported by water, glaciers, ice, wind, or gravitational force. The constant collision and gravitational falling of the rocks cause them to slowly break apart into progressively smaller particles. Flowing water is the primary medium of abrasion, and it reduces the rounded shape of the fluvial coastal sediments. During the abrasion process, rocks may also weather the bedrock or the parent rock surface they are coming into contact with, as well as breaking into smaller particles and eventually individual grains. Bedrock weathering through abrasion may produce a smooth surface, as shown in the figure that appears on the screen. So now, the chemical weathering. It decomposes, dissolves, alters, or weakens the rock through chemical processes to form residual materials. This process, the chemical weathering, involves in carbonation, hydrolysis, hydration, oxidation, solution. And let us discuss each of these processes in detail. The first, the carbonation, is a process by which carbon dioxide and water chemically react to produce carbonic acid, a weak acid that reacts with the carbonate minerals in the rock. This process simultaneously weakens the rock and removes the chemically weathered materials. For example, the carbon dioxide in the air mixing with the water turning into carbonic acid. The calcium carbonate plus carbonic acid further turns into calcium ion and then bicarbonate ion. Like that, this disappears or the mixes with the sedimentary rocks. Carbonation primarily occurs in wet areas, moist climates, and affects rocks both on and beneath the surface of the earth. Carbonation generally occurs with limestone or the dolomite rocks and usually produces very fine clayey particles. The karst topography is the best example for the carbonation processes. The figure on the screen discloses to you about the chemical weathering forms. After the forms formed after the chemical weathering, that is carbonation process. The next is hydrolysis. Hydrolysis is a chemical reaction between H and OH ions and water and the minerals in the rock. The H ions in the water react with the minerals to produce weak acids. The reaction creates new compounds which tend to be softer and weaker than the original parent rock material. Hydrolysis can also cause certain minerals to expand, which also facilitate mechanical weathering processes. Hydrolysis commonly impacts igneous rocks because they are composed of silicate minerals such as quartz, feldspar, which readily combine with the water. Hydrolysis may also be accompanied by hydration and oxidation weathering processes. The hydrolysis of feldspar produces the kaolinite, which is a clay that's shown on the figure, shown in the figure that appears on the screen. So these are the forms by the hydrolysis process. Then hydration. Hydration is a process where the mineral structure in the rock forms a weak bond with the H2O, that is water. Mineral grains expand, increased stress promotes the disintegration of rock. Often color changes in the weathered rock surface. Once hydration begins, it accelerates other weathering processes and may also be accompanied by the hydrolysis and oxidation. An example of hydrolysis: anthracite can absorb two water molecules to become gypsum. Hydration and granite transforms feldspar minerals to clay and accelerates the physical weathering of buried or exposed rocks. The next is oxidation. Oxidation process occurs when an ion in a mineral structure loses an electron to an oxygen ion. This is common in iron-bearing, rock-forming minerals. Ferrous iron oxidizes to ferric iron. Oxidation accelerates rock decay, rendering it more vulnerable to the other forms of weathering event. Next is solution. It occurs when the minerals in rock dissolve directly into water. Solution most commonly occurs on rocks containing carbonates. Also affects rocks with a large amount of halite or rock salts. Solution of large areas of bedrock may cause sinkholes to form, where the large areas of the ground subside or collapse, forming of a depression. Now, we discuss about the biological weathering. Biological weathering is the disintegration or the decay of rocks and minerals due to the chemical or physical agents of organisms. The biological weathering involves organic activity from lichen and algae, rock disintegration by the plant growth, burrowing and tunneling of organisms, and secretion of acids. Now let us discuss about each of these processes. The lichen, algae, and decaying plants. Organisms such as lichen and algae often lie on bare rock and extract minerals from the rock by ion exchange mechanisms. This biochemical weathering process leaches minerals from the rock, causing it to weaken and break down. The decaying of plant materials can also produce acidic compounds which dissolve the exposed rock. Organisms' growth across the surface may also exert a small amount of abrasion and pressure that gradually cause the mechanical weathering of the rock. The figures that appears on the screen discloses you about the biological weathering processes. The plant roots, they penetrate into rock cracks and crevices of rocks and cause the rock to split or break into smaller particles through mechanical weathering. The process enhanced in rocks that may already have a pre-existing weaknesses such as fractures, falls, and joints that shown on the figure appears on the screen. Organism activity. Burrowing, tunneling, and acid secreting organisms chemically or mechanically with the rocks. Burrowing organisms disintegrate rocks. Small animals, worms, termites, and other insects. Snails, barnacles, or limpets attack themselves to rocks and secrete acids that chemically dissolve the rock surface that appears on the screen. Now, we will have a look on the differential weathering. Differential weathering, the rates are controlled by the type of weathering process and rock materials. Harder rocks typically weather slower than softer rocks in the same element. The difference in rates of weathering due to the types of rocks, textures, or the other characteristics is referred as the differential weathering. So the figure on the screen describes the a form caused by the differential weathering. The differential weathering processes contribute to the unique formation of many landforms, including the pedestals, waterfalls, and monad mounds, that is Inselbar, isolated mountain, lone mountain, etc. Climate can also produce differential weathering process responses for the same rock type. For example, limestone weather more quickly in wet climates than the dry climates. Yes, friends. So far, we have dealt with the introduction to weathering, definition of weathering, various stages of weathering, factors controlling the weathering, and the types of weathering. In the next session, we will discuss about the another chapter. Till then, stay home, stay safe. Thank you very much. Thank you, Ananda.